Notes, solving systems by substitution, day 2. Just like in the previous day, we are going to have two equations, a system, that's all it is, and we are going to solve by substitution. So to begin with, we will start with step 1. Step 1 is select the equation where either x or y is by itself. Usually that's fairly obvious. So in number 1, y equals 7. That's step 1. Notice that that one has y by itself. Step 2, we're going to take the other equation, the one we didn't select. So 3x minus 3y equals 18. And everywhere that we see, in this case, a y, everywhere we see a y, we're going to put a 7. Okay? So let's replace that. So 3x minus 3 times y is 7, equals 18. So solving this, that's 3x minus 21 equals 18. So we'll add 18 to both sides. What am I doing? Add 21 because we want a zero pair here. That's a really common mistake that people make, so make sure you don't make that. 3x equals 39. Dividing by 3, we find that x equals 13. That tells us when we get down to our answer, we're going to have x comma y, so therefore this is 13 comma something. All right, now I'm going to draw a big line or separate this, and let's go back to the original equation. Take that original equation, so step 3, go back to the original equation. In this case, it is y equals 7. We can't really substitute anything back in because there it is, y is 7. So therefore, our answer is 13 comma 7. Now the way to check this, and I recommend this, is take your x, take your y, replace those back in here. So y equals 7, that one's self-explanatory. 7 is 7. But here, 3 times 13 minus 3 times 7 should be 18. That would be 39 minus 21, and that is 18. So therefore, our answer is 13 comma 7. All right, number 2, step 1, pick the equation where we either have x or y by itself. In this case, it is that first equation. So step 2, take the second equation, negative 5x minus y, and replace, in this case, y with 6 plus 4x. So that is, let me erase that so that I have space for that. 6 plus 4x. Now in this case, we're going to have to distribute. Okay, distribute a negative 1, so that we get negative 6 minus 4x. Okay, and we'll bring down our minus 5x, and all that equals 21. Now to solve this for x, we first need to combine like terms. That becomes a total of negative 9x minus 6 equals 21. Adding 6, negative 9x equals 27, and dividing by negative 9, x equals negative 3. All right, now we can take that answer and plug it in for step 3. We take our equation, y equals 6 plus 4x. Replacing x with negative 3, 4 times negative 3, we get that y equals, that's negative 12, so we have negative 6, which tells us that our answer is the ordered pair, negative 3, comma, negative 6. Okay, now it's a really good idea, I'll keep saying this, to check this. I'm going to take, this is x, this is y, check it back up here. So this would be 6 plus 4 times negative 3. Negative 3, so that would be negative 6. Yes, that's what y is. Now here, if we take x, plug it in here, we get 15 minus a negative 6. So that's 21. There our answer is. That's all there is to it. Okay? Just keep in mind these 3 steps you're going with. Right, number 3. Step 1, select the equation that has y or x by itself. This time it's going to be that second equation. And we will replace every time we see a y in the first equation with 5 minus 7x. So negative 3x minus 2 times y equals negative 12. So we'll replace down there that y with 5x minus 7. Distributing, we get negative 10x plus 14. So negative 12, bring down the negative 3x. Looks like we have like terms here. That'd be a negative 13x plus 14 equals negative 12. Okay, now let's subtract 14 from both sides. We get negative 13x equals negative 26. Looks like this will work out. Divided by negative 13, we get x equals positive 2. Okay, so part of our solution is 2 comma something. Now we'll take that answer, x equals 2, replace it into the original equation. Okay, so step 3, we're going to take y equals 5x minus 7. Well, x we said was 2. So if we do that, we get y equals, that's 10 minus 7, or 3. So our answer is 2 comma 3. All right, number 4. First step, pick the equation, x or y by itself. Looks like the second equation is it. So we'll replace every x with negative 4 minus 9y. So that gives us 7y plus 2 times negative 4 minus 9y equals 3. So we bring down our 7y, distributing there. We get negative 8. So I shouldn't have put the plus down there probably, but okay, negative 8 minus 18y equals 3. Combining like terms, these two guys right here, we get negative 11y minus 8 equals 3. So adding 8 to both sides, that's 11. Negative 11y equals 11. And dividing by negative 11, y equals negative 1. Okay, so y is negative 1. So let's go back and plug it into the original equation. Step 3. Original equation was x equals negative 4 minus 9y. But y is negative 1. So we get here x equals negative 4 minus 9 times negative 1. That should be a positive 5. Positive 5. So our solution, remember x goes first. The ordered pair, x, y, 5, comma, negative 1. That's it. Number 5, let's go ahead and pick that first equation. Y equals 6x minus 15. In fact, on number 6, it's going to be that first equation right there. So, step 2, replace every y with that setup right there, 6x minus 15. So 3 times 6x minus 15 plus 2x equals 35. We get 18x minus 45 when we distribute that 3 plus 2x equals 35. So this, when we combine like terms, will give us 20x minus 45 equals 35. Adding 45 to both sides, we get 20x equals 80. And dividing by 20, x equals 4. Step 3, take that value and replace it in the original equation. Y equals 6x minus 15. X is 4. So that tells that y is 24 minus 15, which is 9. And our solution is 4, 9. Number 6, we've already done step 1. Step 2, replace x with that expression. So 9 times negative 32 plus 4y. Okay, let's see, minus 11y equals negative 88. Distributing, we get 9 times, there it is. All right, so 9 times negative 32. Negative 288. Negative 288 plus 36y minus 11y equals negative 88. Combining like terms, we get 36y minus 11y. So that's 25y. 25y minus 288 equals negative 88. Now we're going to add 88 to both sides. Add 288 to both sides, I should say. So we have 25y equals 200. And dividing by 25, y should be 8. Okay, so y is 8. Now we're going to take that answer and plug it back in, block all that out, to the original equation of x equals negative 32. Negative 32 plus 4y. All right, y is 8. And we get that x equals 32, and negative 32 is 0. So our solution is the ordered pair 0, 8. All right, number 7. Number 7, we'll take x equals y minus 3. There is our equation that's already set up for us. X is already by itself. Replace it back in to the original equation right there. So we'll have negative 3 times x plus 3y equals 4. Replacing that in there, we get y minus 3 here. Okay, now distributing, we get negative 3y plus 9 plus 3y equals 4. Looks like we have like terms, so we combine those two. And those two actually form a 0 pair. So these two are eliminated. So that brings us down to 9 equals 4. Is that a true or a false statement? That is very, very false. There's no way that 9 is ever going to equal 4. That would cause all sorts of problems. So what that means for us is that since using these equations produces something that does not work, our answer is going to be no solution. No solution. And in fact, if I graph those two, okay, if you graph those two, these should be parallel lines. So let me see, that's y equals x plus 4/3. Y equals x plus 4 over 3. And the second one would be y equals x plus 3. Same slope, parallel lines. Since they're never going to intersect, there is no solution to this system. Okay, number 8. Let's try this one. Let's take that first equation, x equals 3 plus 2y. Replace it right in there. So our step 2 is 12 times 3 plus 2y minus 24y equals 36. And distributing, we get 36 plus 24y minus 24y. And I see a problem already. 24y and 24y are a 0 pair. So we get the equation 36 equals 36. Is that true or false? Well, if you notice, 36 is always 36, so this is always a true statement, which means we don't just have one solution, we have infinitely many. Infinitely many solutions. Number 9. Bailey bought 30 cans of Coca-Cola and Pepsi altogether. There were twice as many Coca-Colas as Pepsi. Which system of equations will determine the number of Coca-Colas, C, and the number of Pepsis, P, that Bailey bought? Well, we know that we have total we have 30 of them, right? Means if you put the Coca-Cola, C, and the P together, put those together, you get 30. So it is not B or A. Right, now we know also that there are twice as many Coca-Colas as Pepsi. So the Coca-Cola is twice the Pepsi. D is our answer. All right, number 9. Number 10. Find the value of two numbers if their sum is 82 and one number is 12 more than the other. Well, first, their sum being 82 means that x plus y equals 82. Now, one of them is 12 more than the other. Let's just say x is that one. Is 12 more than the other. So we're going to have y plus 12. All right, so if we take y plus 12, replace it where x is, we have y plus 12 plus y equals 82. By the way, that is step 1. This is all over here, step 2. That's 2y plus 12 equals 82. All right, now, if we subtract 12 from both sides, 2y equals 70. And dividing by 2, we get that y equals 35. So y is 35. Step 3. To find out what x is, we will take 35, replace it with y up here. So x equals y plus 12, so 35 plus 12, and x equals 47. All right, now this satisfies this because one of these is 12 more than the other. 47 is 12 more than y. And also these two ought to add to 82, which they do. Okay, on to number 11. Gil has $2 more than Karen. Together they have $70. How much money does each person have? All right, so the first thing I'm going to do is convert these into some letters. So let's use G and K. So Gil has $2 more than Karen. So Gil has 2 more than Karen. So G equals K plus 2 is the first equation we've got. All right. The second we have is that together they have $70. So if you add these two together, you should get 70. All right. Our first step is to select that first equation, G equals K plus 2. Our second step is going to be to plug this value, K plus 2, in wherever we see G in the second. So that would be K plus 2 plus K, that was already there. There's the G. Plus K equals 70. Combining like terms, we get 2K plus 2 equals 70. Subtracting 2, that's 68 equals 2K. And K equals 34. Karen has $34. Okay, now we know that Gil has 2 more than Karen, which means that Gil has $36. Do those two add up to be 70? Yes. Yes, they do. So therefore, we know our answer is right. All right, number 12. Marco has 150 coins, all nickels and dimes. So why don't we say nickels and dimes? Now before we go any further, we can use that setup right there. We have 150 coins, which means that N plus D equals 150. Okay, next. He has 12 more dimes than nickels. So his dimes are 12 more than his nickels. Now the question is, how many dimes does he have? All right. So first step is to select this equation right here, d equals n plus 12. Step 2, replace it in the original into this other equation right here. So we'll take n plus 12, plug it in where d is. So we have n plus n plus 12 equals 150. Combining like terms, we get 2n plus 12 equals 150. Subtracting 12, we get that 2n equals, well, let's say it's 138. Yes, 138. Dividing by 2, we know that there are 69 nickels. All right, 69 nickels. And since there are a total of 150, 150 minus 69 will be 81. So there are 81 dimes. All right, that is the end of these notes. It would be a good idea to go back and look at some of these again because I think I may have worked through them a little bit fast. So, all right, so substitution. Remember, pick the one equation where either x or y is by itself, in this case, d. Pick that equation. That's our first step. Second step is to take that equation, that expression, and replace it in the other equation. And then we just get to solve a little bit from there. All right, here we go.